Right. How it's in number 2. Hoileng ke nako. Right. Ntho tlo etsang ke ena people, ne? Re tlo shebana le component of the circuit. This is what we will be dealing with. We will be looking at components of an electrical circuit. This is all what we will be looking for or looking at. Now, these components of electrical circuit, we will look at the components themselves. We're going to look at this in a table format. We will try to look at the symbols that accompanies those components. And then lastly, we will be looking at the functions. Because sometimes you can have a component what you symbol the function. Sometimes you can a function what you symbol the component that represents whatever there is. So the first one, we will be looking at a cell. Can I read a cell again? When read again cell. A cell. And then the function this is the source of energy. That is what we have said. We have source of energy which converts chemical to electrical. I'm going in full. That is very unfortunate. I'm going in full. So currently taking a cell. Taking the source of energy. Okay? This is the energy that we have, and then we are supplying the circuit with that minimum amount of energy. And then here we have a cell. A cell is a single. We will say that a cell is a single battery. That would represent a cell. What is this cell? It is the source of energy that we are supplying to the electrical circuit, so that at the end of the day the bulb can glow or the buzzer can do whatsoever functionality that it is designed to do. So what makes it possible? A cell, because the energy has been supplied to the circuit. Right, remember a cell would represent just a single, we will just say a single battery, because a cell has to have an anode and a cathode. So in essence, it is a battery because it converts the energy from chemical to electrical. But when we have more than one cell, therefore we will say that is a battery. So it's like I'm confusing things here. When I say that a cell is a single battery, but we are saying that a battery is a combination of more than one cell. So you just have to understand it in that way. So we have a battery. And what is this battery? When you have two or more cells that are connected in series, because you want to amplify the energy that is supplied to the circuit. So we have a battery. What is a battery? A battery consists of two or more cells. This is what we call a battery. So you will have, for example, let me do this. The first cell and the second cell. So what do we call this? This is what we call a battery. And in this case, we have two cells, the first one and the second one. So more than one cell is a battery, but when you have only one, we call that a cell. A cell. But the functionality is the same, remember. They all provide sufficient energy in order for the circuit to do a task. Again, what is this? This is also a source of energy. Just that you have amplified your energy. You have put in more than one cell so that you can increase the amount of the energy that can be supplied into the external circuit. Then after we grade 12 for the internal resistance and all in them is. but for now this is enough said. So it also converts chemical potential energy to electrical. We are saying this is chemical potential because this is the energy that a cell has. You have potential energy when you have stored your energy and you have not yet used that energy. It is there within you, it is stored, not being used. We call that potential energy. But many of such things will become very clear when you get to grade 10. For now, fela tseba, or this is the source of energy, and it converts also chemical potential energy to electrical. This is all what you have to know. Many of the things in fully, whatever, or a tutorial is always there for you to ponder on, because you need to sit down and think deeper into these things. Then we also have a bulb. We have a bulb. Dulan. How about the mates? Bometsi, Fuluna mates. Eh, I'm a ballet. Look at it, what we make come out. Oh, yes, I can pilogin. Right. Another bulb. The symbol here, bulb. Many times we've been drawing this one. Many times we've been drawing this one. So, get the source of light. The source of light. And then remember what we said. God, there's the source of light. We said now when current passes through this bulb, again, it tries to overcome the resistance of this bulb, and then by doing so, energy is dissipated as light. Again, your non-electron high theta, it comes across the resistance. In the process of trying to overcome that, it allows the bulb to glow. So come on, German, repapalaka electrons, maritona di sabon. And then energy a converter electrical energy to light and heat, because obviously I carry a bulb yeah glow and high glow how it's paramon so this one key, the source of light, it converts electrical energy to light and heat energy. Lightly heated, we are saying that they are energies because everything you light down, it shows urinal energy. Everything you heat down, it shows urinal energy. That is why we are saying that the bulb is a source of light, because when current passes through that, it glows. So come on, Tomang, it is a source that brings out the light. And then what happens in that process of the light glowing? We are converting that electrical energy, because remember, immediately when the circuit is complete, that chemical energy is one from the battery, it gets converted into electrical. So I can bulb, it can electrical energy, and then we are converting that electrical energy into light and heat, because in turn high glow, come on, lighter, and then how it's heater. It is important that you have those fundamentals in place in order to understand exactly what happens in electrical energy. And then we're going to open and close the switch. We're going to open and close switch. Right. Ratseba switch ile open. Ichi. Ratseba switch ile closed. So this will denote an open switch. This would denote a closed switch. And the circuit is not complete. Again, the electron that moves from this side, it cannot jump to the other side because there is a barrier. And as a consequence of that, the circuit is not complete. There will be no source of energy that is flowing in the circuit. It is important that we understand such things. And then these are switches that controls electrical current. So these are the switches that control electrical current. they control electrical current. And then our open switch breaks the circuit and prevents the flow of current. We understand exactly that. Or when the switch is open, the circuit is broken, therefore there will be no movement from a point of high potential to a point of low potential, because the switch is open. So there will be no energy that is dissipated in the external circuit. But when the switch is closed, the electron is able to move in a complete pathway in order to do work throughout the circuit. So this is all just what we are saying. Or an open switch breaks the circuit and prevents the flow of current, whereas a closed switch completes the circuit and allows the current to flow in the electrical circuit. Many of these things we have already spoken about them. Right, and then we have a resistor. We have a resistor, and then we said this is the symbol. Many times I've been drawing this as a symbol of a resistor. Do not forget, Rukausan, you will be writing your electrical circuit test. Tomorrow you will be writing your test, electrical circuit. Kausan, Arasabuan Tuahar, Os, so. This is the symbol, resistor. It resists or it opposes the flow of electrical current. That is exactly what we said. Again, it acts as a barrier. So come on, when the electron reaches this point, trying to overcome the resistance, because this is a barrier, it opposes the flow of electrical current. In the process of trying to overcome this resistor, it tries to the other side, energy is dissipated. Okay? So we say that a resistor resists or it opposes the flow of electrical current. So it resists or it opposes the flow of electrical current. This is the function. Sometimes we receive a resistor to limit the amount of current that flows into a particular component of interest. But here for now we will just say it resists or opposes the flow of electrical current. You can use a resistor to perform different functionalities. Sometimes you can use it to resist or to limit a certain amount of current that passes to a component of interest. Right. Examples of resistors would be bulb filaments, heating wires, elements in the kettle, heaters, geysers, and stoves. They convert electrical to heat energy. So come on, they are resistors. This is what we are saying, guys. We are saying now the resistors, examples of resistors, the bulb filaments. So not the heating wires. Jolokabodi soldering iron. Renalebo elements in the kettle. Come on, Tomang, an element with Manangara kettle. It acts as a what? As a resistor. And then renaled heaters. They convert the electrical energy to heat energy, high glow. Those are examples of resistors. Rebuakabodi geyser, rebuakadi stove. Stove the way osibona osilighter si heater. So convert that electrically to heat energy. It's a resistor in that way. It is important that we understand that. They convert electrical energy to heat energy. So come on, these examples, when current passes through them, they convert that electrical current to heat energy. We refer to them as what? As the resistors. They are the resistors. And then we have what we call a variable resistor. This is a resistor of an unfixed resistor value. You can adjust the resistance of the circuit in order to achieve a specific goal. So we have also what we call a variable resistor. It varies in its resistance. You can be able to increase the resistance or to decrease. Stove. Stove what we call a variable resistor in the knob. Yani we sochamo how so futumalite papa ke o to be stove o 2 kapa sebe 1 kapa ba papa e butwe fast sebe 4 aya taija ile tala ile jwa. So that is what we call a variable resistor. You are able to adjust the resistivity of a certain component. So come on to Mona, we are using this symbol to denote a variable resistor. Merekinya an arrowhead. Kappa. This is to denote a variable resistor. A resistor whose resistance can be adjusted. This is a resistor whose resistance can be adjusted. It can be adjusted. Okay. Or you can lower. It can be adjusted higher. Or you can lower. Let's say a resistor whose resistance can be adjusted higher or lower to allow more current, to allow more or less current to flow. That's exactly what we call a variable resistor. So whatever stove has a low 1, you are allowing lesser current to flow. Has stove has a low 2 kappa 3, you are allowing more current to flow. So come on to among the knob, your stove mole acts as a variable resistor. Aye, my father. And then we have the conduction wire. You will find many conduction wires, more electrical circuiting, all the plasma. More plasma, this conduction wire. You will find it mostly more. And then you know, right. How na taba he? Re buile mono. La ba fela ka listia kwa ke a good. Right, hurry ho conduction wire. We also have a conduction wire. Mona how looks about the TV mo. Hey, how lo the conduction wire that ifumana at the output. Ya plasma TV, but for somebody specialized in electronics. And then a conduction wire is just a wire that carries electrical current over a distance. This is exactly what a conduction wire does. It's a normal wire. The functionality is to carry electrical current over a distance. So it carries electrical current over a distance. That is the function of a conduction wire. And then in the last two, relay an ammeter. It measures the amount of electrical current that flows in a circuit. Okay? Maripoto corona symbol thing is one. It measures the current strength in amperes. Come on, the amount of current that flows. So this one, it measures current strength in amperes. All right, and then a voltmeter. voltmeter symbol thing is so. This is your capital V, and then it measures the potential difference in volts. It measures potential difference because point is a point of high potential versus a point of low potential, and there's a difference in those two anode and cathode. It measures the potential difference. It measures the potential difference in volts. Many of the things grade 11 and grade 12 or na handle ho etsahala eng ka hara battery, and then okay, I understand that fully when we get to grade 12, not fully as such, but a very solid foundation. How fika mole grade 12 because I work about the anode to the body cathode, work about the solid bridge, work maintaining of neutrality and so on, work about the electrolyte. We'll deal mainly with that, or now anode to the cathode voltage, left ink, right ink, okay. Many of the things will be incorporated when you are in grade 12, or maybe even now in grade 11, because the syllabus in the change. When I said it's a hard interesting. It carries the electrical current over a distance. Over a distance. Okay, the function here conduction wire. Unfortunately, no these components of electrical circuit. You have the components, you have the symbol, you have the functions, and then we are done. And then we are fully done. I will ensure the tutorial is made available on our YouTube channel, and then it is your responsibility to sit down, ponder on these things, practice, and then in naseketa kopana lo wena elo teste we ngolo sane kapa we ngole la bara kapa hle fitiso sane test go ngole hle fit